Hello, Assalamualaikum. Today we're gonna continue our discussion on example 4.7. We are still in isolated forward converter chapter. Okay, so let's try to solve example 4.7. Alright, so we are given a forward converter, okay, isolated, okay, to give output of 24 volt and 20 ampere from 320 volt DC source, okay, with a switching frequency of 20k, and you have a threshold current at 10 ampere, okay, and then yeah, so here's the hint, okay, that the isolation is required. So the transformer turns ratio should be in integer, so this is also another hint, okay, integer. And then the duty cycle no greater than 0.4. So you have to take note, okay, all these hints. And then the transformer magnetizing inductance is at 3 millihenry. Okay, so what you have to do in this question, first you have to calculate the turns ratio, okay, of the transformer, and then you have to calculate the actual duty cycle. Okay, then you have to calculate the inductor, okay, and also the peak transistor, the switch. Okay, sometimes I say transistors, okay, and sometimes I say switch. So transistor and switch, they are the same, okay. So sometimes, okay, the diagram might look like this, okay. This is also transistor symbol, or it can also looks like a switch. So both is the same, alright, okay, don't get confused. Okay, so before we can solve example 4.7, I just want to introduce to you the formula. Okay, this, do you still remember every converter has a very unique ratio of the V out and V in, yeah, right? So today I'm going to introduce you the ratio between the V out and V in for isolated forward converter. Okay, this one you have to memorize here. It's very important formula. Okay, so let's say N is the ratio of N1 over N2. And then do you still remember from the previous discussion? Okay, because the N1, okay, N1 and N3, okay, they are very close together. Okay, alright. So because they are close together, we call them bifilar. So when they are bifilar, so means that we can almost say that N3 and N1 is the same. Okay, right. So do you still remember this is the diagram for the isolated forward converter? Yeah? Okay, so let's solve, okay, this problem. Okay, so let's list again what the question wants. Okay, so the questions ask us to find okay, first the turn ratio. Okay, you know the turn ratio is N. Then second, the actual duty cycle. Then third is the value of a L. L is the inductor, this guy here. And then number 4, you are required to find the peak transistor current. So transistor in this is the switch. Okay, so I use the symbol of ISP. Okay, right. Okay, so now we would like to solve number 1. Okay, let me change my pen color. Okay, right. So let's solve the turns ratio. Okay, alright. So you know the formula. Divide by d over n. Okay, right. In the previous question, you are given the duty cycle as 0.4. Okay, so let's use that here. So you know your duty cycle as 0.4. You know your VR is 24. This is obtained from the question, yeah? Okay, then you get your VS, which is the base supply. It's also from the question. Okay, so that. So you can reshuffle this equation, okay, and you will get your N as the following. So that is 5.33. Okay, so that's the answer, right? Okay, but the question says to you the turns ratio needs to be an integer. Okay, but having 5.33 is not the integer. This is not integer. Okay, so integer means it's a round number. It's a 5, 6, 7. Okay, so what you have, okay, so n here is not an integer. So what now you have to do is you have to round it up. Okay, so if you round 5.33, you will get n equal to 5. Okay, all right. So this is the turn ratio. Okay, the new turn ratio. Okay, that meet the questions requirement. Okay, we want the integer. Okay, right. So now, because we have reset n as 5, so means that we now have to calculate the actual duty cycle. So now, when we say n is 5, the duty cycle is no longer d equals to 0.4. Okay, so let's recalculate the actual duty cycle if n is 5. So given V in this formula again, and of course you know your V out and V in. Okay, so okay, so your V out is 24 divided by 320, and then the new D which you want to calculate, you have 5. Okay, so your D is 0.375. Okay, alright, so that's your number 2 answered. Okay, so let's calculate the value of L in the next slide. Okay, so here we want to calculate the value of L. So that is question number 3. Okay, so do you still remember what happened during the threshold? Okay, so in here during the threshold, the question says that, okay, let's change the pen color again. Okay, it says that during the threshold, the inductor current is 10 ampere. Okay, so let's use that information here. Okay, so if you can see here, okay, IL equals to 10 ampere. Okay, so do you still remember how IL look like during the threshold? Okay, this is just for threshold, yeah? It starts at 0 and ends back at 0. This just for threshold. Okay, then you have the average IL, okay, at 10 ampere. Okay, right. So, alright. So if this is the average, means that from this line to this line, okay, from this line to this line, you get is 10. Okay, and this line to this line is another 10. So peak to peak will be 20. Agree? Okay, so peak to peak is equal to 20 ampere. Okay, in order for us to find the L, okay, you have to remember the previous value that we introduced to you when you are solving other converters. Okay, you have this formula divided by L. Okay, alright, so T is 1 over F, D is the duty cycle, VO is the V out, and delta IL. Okay, so let's solve this problem. Okay, you know your delta IL is 20. So let's use that information. And you know your V out as 24. Okay, and you know your frequency. So here your frequency is given as 20 K. Alright, so that will be 1 over 20K. Alright, and your D, make sure that you use the one that you calculated, yeah? Not from the equation. Okay, so you use that one, divide by L. So you reshuffle equations and you get L as 22.5 micro Henry. Okay, right. So let's calculate the last question, number 4. Okay, in the last question, ask you to calculate the peak transistor current, which is the IS peak. Okay, so in this part, I'm going to introduce you to a very important equation that you have to remember. So peak, IS peak, okay, equals to N2 divided by N1 IL current at the peak plus I magnetite. Okay, alright. So in this formula, okay, in order for us to calculate, in order for us to calculate IS peak, we have to know, okay, the ratio, the IL peak and I max. Okay, so you know that, okay, this color is not very clear, so let's use blue. Okay, you know that your N2 divided by N1 is the same as 1 over N. So that will be 1 over 5. Okay, we don't know IL peak. Okay, so we're going to find IL peak now. Okay, let's calculate. I'll pick in this part. Okay, so do you remember just now we draw the threshold IL? Okay, so now we're gonna draw the IL, but this time at the full load. Okay, so this is IL, but this time, okay, the graph, the waveform is at the full load. Okay, so at the full load, okay, at the full load, let's see the question. At the full load, the IL now is 20 ampere. How do you know? Okay, because at the output. So the output is always operating at full load. Okay, so you know it's at full load. Okay, so this one, the IL will be 20. Okay, so previously we says that peak to peak is 20. Okay, so means that this, okay, this is called, this point is called IL peak. Okay, so this one means that this at 10. So IL peak will be 20 plus 10. You get 30. Okay, so now good. You already know your IL peak. Okay, what about your Imac? So let's calculate Imac. Okay. So do you still, okay, so I'm going to introduce you to another formula. Okay, Imac Vs T D divided by Lmac. Again, T is 1 over F. Okay, so you know your Vs as 320. You know your frequency as 20K. Okay, and you're still using the same duty cycle. Okay, and you know your Lmac. Lmac is given in the question as 3 millihenry. Okay, so if we see the question give us this 3 millihenry. Okay, so we're going to write that 3 milli. Okay, so Imac is calculated as 2 ampere. Okay, fantastic. So you know your Imac and you know your IL peak. So now you can calculate your IS peak. Alright, so your IS peak is given as 1 over 5, okay, times by IL peak. So IL peak, okay, IL peak is taken from here, yeah. This is IL peak, the one that you calculated. Okay, so that's your IL peak value. Okay, and then plus Imac 2. Okay, so you get your IS peak as 8 ampere. Okay, so that's all for example 4.7.